Okay, so now we're going to do proofs that are a little bit more complicated. I'm going to give you guys plenty of time in class to fix your homework. So I'm just going to do these 4 proofs and then have you practice. So we're going to talk about things that you can conclude. And I'm going to do basically the same thing. I'm a big fan of highlighting. I think that that's important. So I'm going to write, so the first thing I'm given is BD is parallel to GT. So I am going, BD is parallel to GT. So I'm just going to mark that in my diagram with the same arrow. So that's given to me. Okay. The next thing I'm given is BD is congruent to GT. So that's also given. You can use those marks. So I'm actually going to highlight this there and there. Right now, I only have one thing, and I need 3 things to prove congruence. So I'm looking at this here, and I'm like, so I look for things like, do I have reflexive property? Okay, so I look at this here, and I realize that I do. I know that DT is congruent to DT. So that's going to be reflexive property. So I have one thing here, I have 2 things. Now I'm looking for a 3rd thing. But we have this piece of information that we haven't used yet. We're given that BD is parallel to GT, okay? And so we're going back to Unit 2 with parallel lines. So if I know that these 2 lines are parallel, then I know this angle here must be congruent to this angle here. I know that angle GTD must be congruent to angle BDT. And we have this name. This is alternate interior angles theorem. Which just says the alternate interior angles on parallel lines have to be congruent. Now I have my 3 things. I have 1, 2, there's my 3rd thing. I have 2 sides and an angle. I look, yep, my angle is included on both of them. So this is going to be, so I know triangle BTD must be congruent to triangle GDT by side angle side congruence. Okay. All right, so that's the first one. So these ones, you're just kind of going to extend it. You're going to be using some of the things that, about parallel lines and stuff. So the next one is, so you're given AB is parallel to DE. And so in the back of your mind, you're going to start thinking about your angle relationships. So that's given to you. You're also given C is the midpoint of BD, and that's also given. And so I can't mark anything in the diagram because I really haven't said anything was congruent. So right now I have nothing. But I look at what I'm given, and I think this is the easiest one, is if C is the midpoint of BD, okay, then BC must be congruent to CD. And that's because, well, that's the definition of a midpoint. A midpoint divides a segment into 2 congruent parts. So definition of midpoint. Okay, now we're given that other piece of information we haven't used yet. So we have not used the fact that these 2 lines are parallel. AB is parallel to DE. Now I have a side. All I need is, I need another side or angles. There's nothing more that I can say about the sides because it just says that C is the midpoint of BD. It doesn't say that it's the midpoint of AE, so I can't use that. So for this, I also know that, actually I'm going to backtrack just a sec, sorry about that. I know that this angle has to be congruent to this angle because they're alternate interior angles and those lines are parallel. So do you see that they're both on BD and then the other side of each angle is a parallel line? That's how you know. So I also know angle ABC, and you could call that ABC or ABD, must be congruent to angle EDC. And that's going to be alternate interior angles theorem, you also have another pair that you can talk about. So I also know angle A, actually, there we go. Angle A must be congruent to angle E, or angle CAB, but I can name it with one letter. Angle A must be congruent to angle E. So you could have named these with one letter too. Also the same reason, alternate interior angles theorem. Now I'm looking at this, I have two angles and a side. The side is non-included on each, so I know triangle BCA must be congruent to triangle DCE by angle, side congruence. We can call it theorem, THM if you want, that's theorem. THM is theorem. Okay. So these last two. All right. You're given, so this one I can mark. I know BC is congruent to DC, and you can use the tick marks if you want, if you don't have different colors. So, but on Desmos, or not Desmos, on formative, you have the color. So BC is congruent to DC. That's given to you. You're also given that AC bisects angle BCD. So AC bisects angle BCD. Now I can't mark anything in my diagram, but here is angle, and I'll just do this. So here is angle BCD, okay? If it's bisected, then I know for sure that this angle must be congruent to this angle, okay? They have to be congruent to each other because definition of bisect. So I know angle BCA must be congruent to angle DCA, okay? And that's because, well, that's a definition of bisect. Bisect means to divide into two congruent parts. Okay, so right now I have two things. I have one, that BC and DC are congruent, and two, BCA. Now, when I'm looking for a third thing, I look for things like vertical angles and reflexive property if I'm not given any additional information. What I see here is they share AC. I know AC is congruent to AC, a side is congruent to itself by reflexive property, okay? And so now I have three things. It is two sides and an angle, okay? So I have a side here, an angle here, and a side here. This angle is included, so I know for sure triangle ABC is congruent to triangle ADC by side, angle, side, congruence postulate, if you will. Okay, this last one's a fun one, okay? So you're given DE is parallel to CB. It's marked in the diagram, okay? So I don't have to do anything. You're also given DG is parallel to CA, okay, which is also marked in the diagram still. And you're given, and you can put little tick marks if you want, and then you're given EG is congruent to BA, okay? Now that'll actually mark, so EG in BA, all right? I'm gonna say besides reflexive property, 90% of the time, once you're kind of at a stop where you can't find any more information, start looking at the angles and relationships within the angles, because that's where a lot of it is going to be. So I look at this, I only have one thing right now, but I'm given that these angles are congruent, or these these lines are parallel. So I'm just gonna kind of make this longer. So I'm gonna make these two longer because I'm gonna look at these. I'm actually gonna erase this in a minute. So I have those two parallel lines, and then I have this, which is our transversal that kind of goes through. And I kind of ignore everything else except for what I have here. So, and so I'm looking at this, sorry about that. I'm looking at this and I'm like, oh, wait, I can see that these are alternate interior angles, these angles here. Okay, and I know that those lines are parallel, so those angles must be congruent. So one of the things I'm going to be able to write is I know that angle DEG must be congruent to angle CBA. So CBA by alternate interior angles theorem. And most of the time it is going to be alternate interior angles. Okay, so I have that. I'm going to erase my little orange lines. Okay, so we have there. Okay, so now we have two things. We have one here, we have one here, and then we have two here. Okay, so now let me look at my other parallel line. So I'm also given, and I actually wanted to do this. Here we go. Okay, so I'm just going to make my other parallel lines a little bit longer. Okay, so these are my other parallel lines, and here is my transversal. And I look, and there's no angles that are in the triangle that are between the lines. But what I notice is, well, I have this angle, and let me do sparkly. I see that this angle here and this angle here, well, those are congruent because those are alternate exterior angles. Okay, so I can see just by kind of, don't look at everything, but just kind of extend your lines. Well, what else could be congruent? Well, these are both inside the triangles. Okay, that's the only thing that they have in common, and they happen to be alternate exterior. And so I also know that angle DGE must be congruent to angle CAB. Okay, and instead of alternate interior angles theorem, this is going to be alternate exterior angles theorem. So that's going to be my third thing. So I'm going to erase this, there, there, and there. Okay, now I have three things. I have two angles and a side. Two angles and a side always work. You just have to figure out. So I'm going to say triangle EDG is congruent to triangle BCA. And for this, my sides included. Okay, so that's going to be by angle, side, angle, congruence postulate. So those are that. You have the rest of class to work on these. I definitely need to give you feedback, so you're going to need a lot of practice with this, but that's all we're doing.